All right, so our final version of our trig sub quiz was a fairly simple one. We had a lovely little substitution using sine. We could know that this is sine because we have this idea that 1 minus sine squared theta is equal to cosine squared theta. If we rearrange our Pythag theorem, we could also go look at the antiderivative for one, or I guess we could do it with the a squared minus x squared inside of a square root. That antiderivative is sine inverse of x over a plus c. So both of these things sort of give us that idea that if we have a number, especially a squared number, out in front, right, and then we have a variable that's squared behind a minus, right, so this one's the negative in terms of our two different terms in this situation, that we should be using sine as our substitution. So if we do that, we say x squared. I need this to just be 16 sine squared x, because if that's true, this whole square root would be 16 minus 16 sine squared x. I hope I didn't go outside the area of my recording, but who knows. Which we could then factor a 16 out of both those terms. That's why we need those coefficients to match. And we'd have our 1 minus sine squared theta, which we know from our Pythag identity is 16 now cosine squared theta, which we can go ahead and remove that square root by going ahead and square rooting that square. So this is sort of why we're choosing that. We do need to do a little bit of work. We just figured out what the entire square root section of this is, right? This entire, radicand, right? Basically our whole integrand here. We figured out all of this. That's what we just said was equal to 4 cosine theta if we do this substitution. However, we have not finished because we still need to replace that dx so that everything is in theta. So let's go ahead and pull back to that x squared is equal to 16 sine squared theta. So that means my x is equal to 4 sine theta, which means my dx is equal to 4 cosine theta d theta. Now at this moment I could also draw the triangle that I know I'm going to need eventually, so I could sit there and be like, okay, well, let me use this to say x over 4 is equal to sine of theta, which means I can draw my cute rectangle. Sine is opposite over hypotenuse, and then I could use the Pythag theorem to find the thing that we were originally substituting for in the first place. This is why we can go, oh yay, this is my check. All right, so let's go ahead and rewrite our integral with that new substitution. We said everything inside of the square root was just 4, or actually everything including the square root was 4 cosine theta. We went out and found our dx to replace. That was also 4 cosine theta. And so our new integral that we need to be able to take the antiderivative of is 16 cosine squared theta d theta. So if you got this far, you got 4 out of 8 points. Some of y'all got stuck here, but we have an even number of cosines or sines, and so that means we should use those power reducing identities. So this is 16, I'll go ahead and bring the 1/2 out in front, 1 plus cosine of 2 theta d theta. This is something we can go ahead and take an antiderivative of. We will have 8 theta. We'll have 8 plus, if we take the antiderivative of cosine, do we still say positive? Plus, yes we do. 8 sine of 2 theta divided by 2, because there's a baby u sub happening there and I didn't want to bother with the u sub, plus c. And now we've got to use our triangle to finish this problem. We're going to use a little bit of both things actually. We're going to use the, I guess I'll stay in purple land, because we need to write out what theta is, and so to get theta alone we have to do sine inverse of x over 4 to get that theta alone. So now we have 8 times our sine inverse of x over 4 plus, and here's where we get stuck. Unfortunately, my triangle is about theta, it's not about 2 theta, so I have to use another trig identity. This trig identity is our double angle for sine. The double angle for sine tells us that sine of 2 theta is equal to 2 sine theta cosine theta. And so I guess that 2 will cancel with the 2 in the other part. So we'll have 8 again. And now our sine of theta is still the original sine theta we had in purple. That's our x over 4. And we have to figure out what cosine is based on our triangle, which is our, my goodness, adjacent over hypotenuse. And so if you wanted to, you could go ahead and deal with these 4s, make that a 1/2, but this is perfect. You don't really need to go any further than that. We are done.